In this second video for the Part A lecture notebook of Module 3, we discuss user-defined functions in Python. User-defined functions are the types of functions that you want to create when you find that you're reusing over and over again the same type of functionality that can be encoded inside of a function. And by putting it inside of a function, you're making the code easier to read, use, and debug, because if you want to change anything, you're just changing it inside the function. You don't have to change every place where that type of functionality is encoded over and over again, which leads to lots of copy and paste errors. You've collected it all inside of the function. Now, the syntax is similar to what we saw with the if-else if in terms of we need this colon that's after the statement, like after, you could think of the function name as kind of the condition, but you need this colon after it, and then everything's interpreted in terms of indenting. But that's kind of where the similarities end. What we have that's very unique to this is the idea of this DEF to define a function with a given function name that you would assign it. You would give the parameters, which are the inputs to the functions, and then you would make sure to separate if you have multiple parameters. It's a multivariate function. It depends on many different inputs. You just make sure to put parentheses between all the different parameters. And then you would have a doc string. This is just in terms of how you document things about your function. That's very useful for help files. And I have a whole bunch of information down below that I'm not going to read to you in this video, but I highly recommend you read it carefully and you explore some of these links and things that I'm talking about proper documentation. And in fact, you are going to be asked to create doc strings in various functions and in notebooks throughout the rest of this course. And then you'll have all the things your function's supposed to do, again, all with the right indenting. And then you'll either return, or you don't have to return. If you don't want to return anything from your function, it's just going to operate on things, but maybe make plots, maybe print things to screen, but maybe you don't want to actually return any output. This return is optional, kind of like the else statement is optional. And that's kind of it. That's the basic structure of a function. And we're going to start getting into some examples of it below. So there's something important to understand about the parameters and the keyword arguments in a function. In the definition of a function, we have the parameters variable, which is often a list of parameters as shown below. For instance, here's my first function that I'm defining, and I have x and y as two parameters. And notice I separate them with a comma. So that's what I mean by a list. I don't actually mean like a list as in with the square brackets. It's just a collection of inputs. These are normally ordered unless you supplement them with keyword arguments in the function call. So because I'm assigning x and y here, I just want to make this clear before I even run this code cell. If I run this function, this is my first function, if I give it the inputs 2 and 3, then x is assumed to be 2, y is assumed to be 3, because they're just positional. They're just ordered. 2 is the first number I'm giving, 3 is the second, and x is the first variable here, and y is the second. However, as you see below, I'm going to show you that I can actually use the variables that are part of the parameters list inside of the function. And if I said x equals 2 and y equals 3, then I can switch the order. Y equals 3 and x equals 2 will give me the same output, because it's going to still assign this to x. So if you call the function and you use the parameter names that are in the function definition, when you're assigning the variables, then the order of it doesn't matter. It just assigns it according to the actual variable name. So that's something really good to be aware of, because sometimes you forget the order of parameters in a function, especially if there's quite a few, and you just say, well, I know it has x, y, z, or whatever they are in the function. And if you just go ahead and say, okay, well then x is equal to something, y is equal to something, and z is equal to something when you call the function, you can rest assured that the function will operate the way you intended it, with those input parameters being assigned a proper value and not worrying about remembering the order in which they have to be inputted. So that's very useful to know. So let's go ahead and look at this function. So this first function, notice I'm defining the function. I have the colon here. That's all very important. I have my little doc string, which just explains something about what the purpose of this function is, what it's doing. And again, you should read through this brief thing about this doc strings and commenting in your code. And so now, if x is less than y, then I create the variable z that is equal to x plus 2 times y. Otherwise, that's the else, And remember, I'm doing if else, and so I have these conditions that I'm checking. If x is less than y, so if that's true, z is equal to x plus 2 times y. Otherwise, the else, z is equal to x minus 2y, and then I return z. Okay, so I'm going to run that code cell, so it's created that function. And now look, if I do help my function, it actually prints some information about that function, including, this is another nice thing about using that help function. If you ever forget what the positional order is, it will show you what the order of the parameters are. So there you go. It has this information, and it tells me something about how to understand what's going on with this function. This function returns x plus 2y if x is less than y. Otherwise, else it returns x minus 2y. So now let's go ahead and print, my function evaluated at 2 and 3. So if I put 2 and 3 here, that's kind of like what A and B were in the first video. 2 is less than 3. So that should return 2 plus 2 times 3. So 2 times 3 is 6 plus 2, that should return 8. So let's see, if I run this, it returns 8. Now notice I gave it ints and it returned 8. If I looked at printing, for instance, I'll just go ahead and create a new code cell above. If I looked at printing the type of variable that is returned here, you'll see that it is an integer. The inputs were integers. All right, I'm going to go ahead and delete that. Now, I created and returned a variable z. Here's something to realize, and I think I also showed this later, but I'll just go ahead and do it now. I'll create a new code cell right here. If I look to print z, you will see that the name z is not defined, because even though I returned z, it existed only inside this function, and I returned it. It's just a variable that it's just returning the value of this variable's value effectively that's created within this function. I didn't store it as anything. I just used this function to evaluate 2, 3. It created this variable here. It returns the output of it. You see 8 is returned, but that z is not actually stored anywhere in memory in this main space that I'm working in. So that's something to really keep in mind, and we'll come back to this idea a little bit more when we talk about pass by value, pass by reference in the final video of this lecture notebook. I'll go ahead and delete that. Now, if I use 2.0 and 3.0, those are both floats. And so you probably are not surprised to see that the output is also a float. It's 8.0. If I switch the order, well, now I know that this is no longer true. The 3 is not less than 2. So it should return what? 3 minus 2 times 2. So it should return -1, and it should be -1.0 because those are both floats. So that's exactly what it returned. Now, if I make x equals 2 and let's say y equals 3.0, in that case, I have an int and a float. But when they get combined, what we'll remember from module 2, the very beginning with these variables in terms of ints and floats, is this should be cast as a float because that's the most flexible variable type that makes sense of this operation combining an int and a float. So this should, of course, return the 8.0 again. Now, if I switch the order, but I've keyworded it, so y is 3 and x is 2, and we're here x was 2 and y was 3, and it doesn't matter if they're both floats as long as one of them is a float, the output should still be 8. And it's exactly what you see here. And again, that shows why using keyword arguments is kind of nice. It's always going to make sure that things are working exactly as you want. You're not relying on the positional order being true, like that you've remembered what the positional order is correctly is what I should say. So one thing that I also want to point out is if you start using keyword arguments and then you want to rely on positional order, you're going to have a bit of a problem here. So like, watch this. If I run this, you're going to see I get an error. It's a syntax error, and it's telling you exactly what the problem is. A positional argument is following a keyword argument. That is not allowed. Once you commit to using keywords in a function call, then you better be all in. You need to use it at least in all the parts of the code that follow. However, you could say, well, geez, I remember what the first few inputs to my function should be. This was, excuse me, I'll just change that. I'm going to add a code cell above this actually. So let's just go ahead and put it right here. So right here, let's say I want to print my fun one, and I'm going to have 2 and then y equals 3.0. All right, that's just fine. If you remember, let's say your function has 7 arguments to it, 7 parameters. And let's say you remember like what the first 3 are positionally. You know that you're just putting them in, you're not keywording them because you just remember what they are and you know what you want to put in for them. So let's say it's X, Y, Z, W, U, and so on. And you go, well, I know X, Y, and Z are the first 3. So, and I know they're in that order. So you don't necessarily need to input x equals, y equals, and z equals. You can just be like, here's the value, here's the input for those in order. And then at some point you go, oh, I don't remember what the variables 4 through 7 were, those parameters. I don't remember what their positional ordering was. Well, as long as you have the names, if you know what they are, it doesn't matter. You can start. It's just once you start, you need to keep with it. That's what what I'm showing right here is demonstrating. Is you can start with positional arguments and switch to keyword at any time, but once you switch to a keyword, you need to keep with it after that, and that's what is being shown in this one right here. This will produce the error, and rightly so. A positional argument cannot follow a keyword, but a keyword can follow a positional argument. Now, I've shown you that I can run this with ints and I can run it with floats. What happens if I try to do something like silly test as my inputs? Well, it produces silly test. You kind of go, what is going on here? Well, and now I'm trying to print z again, right? And z is just nonsense, like this hasn't been defined. But what am I doing here? Silly and test. Well, silly is the x and test is the y. And what it's doing is it's trying to compare strings. Now, one thing you might remember from something we saw in Module 2 in a notebook is that you can't compare different data types. Like I can't compare an int to a string or a string to an int, which is the same thing. But I can compare two ints to, and you compare ints and floats actually, but I can't compare like a string to a numeric. But I can't compare a string to a string. And so what it's doing is it's saying, well, is silly less than test? And what it's checking in that case is like, well, S is coming before T in the alphabet. So it's treating this like it's something that's less than this one. That's what's happening because it's taking silly and it's adding to it test. It took 2 times test, right? Because 2 times a string is just going to create 2 copies of that string. And if you add 2 strings together, it's just concatenation. So I have the space here, and you just see I literally took silly plus test. It went through this part of the code. Now, if you try to reverse this, so I'll just go ahead and add a code cell above. If I just looked at my fun one and I just did test and then silly, I'm going to run into a bit of an issue here because now test is greater than silly, right? Because silly was less than test. So it went to the else part and it tried to run that part of the code, but now it's trying to take a string and subtract a string from it. That is an unsupported operation for string subtraction. So I'm getting a type error from that. So this is kind of important. Like I'm allowing the code, like this is the thing with Python, and we'll talk about this a little bit more in a second. But you can put in kind of any variable types you want into a function. And unless you're encoding some type checking to make sure that the code is getting inputs it's expecting to do the operations that you want to code inside that function, sometimes it might work, sometimes it might not, depending on the order in which you even put these really weird variable types. So it's something to really be aware of, is that you can kind of get away with murder in some of these Python coding in terms of like the types of variables you give it. Like you look at this code and you would think, I'm of course just supposed to give it numbers. But we just saw that it does run with strings sometimes, but not all times. And so that can really get you into some weird issues inside of code if you're not careful and very intentional with your coding and how you're using functions the way they were intended to be used. And also if you're writing your own user-defined functions, sometimes making sure to check the variable types that are in there, which again, we're going to come back to. But let's just go ahead and keep going. So I've already pointed out Z is not defined. I just had this already in the code. However, I can assign Z to the output, and then now Z is stored inside the code, inside of this main namespace. This variable Z is defined. But if I run my function like 47, excuse me, that defines 18. Now that defines Z, right? That defined this Z, and it returned it. But I didn't assign this to Z again. So the value of Z, now that it's defined, didn't change. So there you go. You can play around with this function some more. You can create your own, start, playing around with different inputs just to get a sense of what's going on. Highly recommend that. But that's it for this part of the video. I'm going to pause, let you hopefully play with your own stuff, and then we'll come back to functions and type checking in just a second. So we mentioned just previously in this video and above in this notebook that functions do not do any type checking of inputs unless you put it in there. So you can put any type of input you want into a function. And in fact, users will often do that. They'll try to run functions with inputs that are not of the types of variables that the function was designed to handle. And the way that you want to perhaps handle this flexibility, because it can be useful, but maybe it can cause some issues that are undesirable or makes the code really complicated to understand what the outputs are going to be if you start getting variable types that you weren't anticipating for the function that you're writing. You can incorporate logic along with some built-in functionality with types to check that the types are what you're expecting. But what you should really be doing, the real community standard for type checking, is to use isinstance. So isinstance is checking, like, is this variable, like what you're giving with isinstances, you're saying, is this variable type of a particular collection of types that I'm okay with having in the function? Like, that's what you're checking, and it returns true or false. So this is better than just using type in logic. You just want to use isinstance. So I'm going to give you an idea of this. I'm not going to dwell on this really much in this notebook. You can do some other things, like to check variables before computations are done. You can put try commands in, like we've seen before. I just want to give you an idea of how you can do this just for your own benefit, just to complete kind of your own set of knowledge from this. So what I've done above is I've copy and pasted that my function fun1. So this won't be in the notebook. You can add this again. I just went to where the function was up above. I copied it. Let's see, just scroll up there, right there. I copy and pasted the contents right here. Now, it's pretty clear that when I designed this function, when I wrote it, I was expecting x and y to be numbers. However, we saw when we run something like silly and test for x and y, it still runs without error. And if we run test and silly for the inputs positionally, so x is the test and y is silly, then we get an error because you end up trying to subtract two strings, which is not an allowable operation for string types. So you kind of say, well, it could or couldn't run, it might or might produce an error if I don't give it ints or floats. If we give it ints or floats, everything will work fine. So what you would want to check is, are x and y instances of an int or a float? So just to give you a sense of how that works, I'm going to insert a code cell here just to show you how isinstance works. So if I put isinstance, and let's say I put x, I'll actually just do this. I'll put like 2.0 just to give you a sense of what it is like. So 2.0 is a float. And if I put int and float as a tuple, so that's what I have here as a tuple, then it's going to check if 2.0 is one of these two things. And if I run this cell, so if I run it right now, you'll see that this is true because 2.0 is a float. If I make it 2 and I run this, I should have had control enter, it is also true because 2 is an int. Now if I give it, let's say 2 with ticks around it, now it's a string. And if I run that, that's false because that string is neither an int nor a float. So that's basically how isinstance works. Now, what I could do for this function is I could check, look, I want to make sure that x and y are both integers or floats, right? And if it is, I want it to run. Otherwise, I want it to tell the user something like, this function was intended to run only with numbers, and then just return, not give any value of z. I just want it to exit the function. So to do that, I'll just start writing, okay, if isinstance x, and I want to have int and float, so that will check that, and I want y to also be an int or a float. And then I go, okay, this is, if these are true, I want everything to work. So what I want is if these are not true, so not, and I'm going to put parentheses around the whole thing. So if either one of these things is false, then both of these, because it's an and, will be false. And then I'm taking not and saying that will turn it to be true. All right, you got to follow that logic there. I know that might be a little complicated as you're getting used to it. And what I want to then do is print something to the screen to let the user know what's going on. This function is expecting numbers to run properly. And then I will return. As soon as I do return anywhere, if that return is ever executed, the function is left. Like it leaves the function. So now if I run this, so I've defined my fun1, I've redone it over, and I now go back to my fun1 and I put silly and test, which we know ran with these strings. We know it ran before. What it's going to do now is it's going to print that output. this function is expecting numbers to run properly. That's what it ran. It never did this computation here, right? We don't see anything printed to screen. So that's what happened. When I ran this function, this was made to be true by that not, because I gave it an x that was not an integer or float. I gave it a y that was not an integer or float. So both of these were false, in fact. And of course, then the and only requires one thing to be false. Then that not made it a true, so that it would say, okay, this is not what I'm expecting. So I want to leave the function and give the user some useful feedback. This function is expecting numbers to run properly. So I just want to give you a sense of that. This is just really for your own benefit. I'm not going to dwell on this, but it really helps develop your way of thinking when you're writing these functions. You could be writing it very specifically in mind. Like when you write this function myfun1, you might never think to do any type checking or have anything like this. And you might think, well, no one will ever try to run this with anything other than I intended when I wrote the function. But the users of your code are not you. They are going to potentially try to use it in ways that they shouldn't. And it could have harm that happens in their code or whatever the inferences or policies that are derived from the outputs of that code. So responsible code writing is really kind of suggesting you should do some type checking. Now, I'm not saying you have to do this all the time. It depends on what you're doing. And we're not going to do a lot of it in this course. But if you're going to do this professionally, if you're going to work with collaborators, it's a good idea to institute some type of code checking in really mission critical functions. So that's it. That's this part of the video. That's all I wanted to say before we go on to default parameter values. In the last part of this second video for the Part A lecture notebook, before we get to the third video for this notebook, we're going to talk about default parameter values. So here's some key points. Python allows you to set defaults within the parameter list of a function call. What are defaults? Well, we'll see. Like in this function, for instance, I'm defaulting y to be equal to 2, which means that I never actually have to assign the variable y, when the parameter y, I should call it, when I'm calling the function, if I'm happy to just use the default value. Defaults, just like with keywords, need to come after function parameters with non-default values, just like the keyword values had to come after positions. So if you have some function parameters that you do not want to set default values for, you should put those before any parameters with default values. Just like how we had positional and keyword arguments discussed previously in this video. A parameter without a default value is called simply a positional argument, even though you can use a keyword to call it. It's still just called positional. Let's tweak the myfun1 a little bit to see this in action. So here I'm going to create myfun2, my function 2. And I'm going to default y to be 2. I'm just going to put a space there. I like to have spaces between, list of things that are separated with a parenthesis. So all I'm doing is I'm defaulting y to be 2. Now, this will produce an error. X has no default value. So if I call myfun2, and it's a function, so I need to have the 2 parentheses there. If I call this, it's going to say, well, you're missing one required positional argument, x. Notice it didn't say I'm missing 2 positional arguments. If I made this myfun1, you will see I'm missing 2 positional arguments, x and y, because I did not have y defaulted in myfun1. However, myfun2, I only have x as the non-default. I have y as a default. So I have one required positional argument in order for this to execute. So if I give 1.0, nothing else, this will use the default value for y. So there you go, run. And I won't go through it, but you can check that this is what the output should be if x is 1 and y is 2. You can go through this yourself. Now, let's say I wanted to change what y is. I don't actually need to use a keyword. I can input everything positionally. That's pretty much always okay. So if I run that, x was 1, y is 3, and again, you can check for yourself that this is what the output should be, that it should be 7. Now, if I want to keyword things, I can, and then of course the order doesn't matter. So there we go. And then one thing I want to point out is I could go ahead and I could take, like, say, myfun1, and as arguments, I could use the outputs of myfun2 as the x and y values, right? So you can nest functions together, just like a function composition. So this is basically like a function of a function evaluated at x and y with the default y that's used because I'm only passing one positional argument. And then the y value, I'm using myfun2 with the x and y value. And notice I'm doing the thing where it's positional and then I'm keywording the y after that. So I could run that. Everything will run just fine, gets the output of 19. try to figure out if that is the correct, I mean, it has to be the correct output. It ran and it gave what it is, but see if you can make sense of it. So that's it. This is a very short part of the video. We're going to end there. The rest is just activities, and then we will conclude with the third video. It's its own separate entity that discusses pass by value and pass by reference.